Hello classes, this is Mr. McAllen, and I am going to be working on the open-ended review problems. And now remember on these open-ended problems that there is partial credit given for these answers, so it's always good to give it a try. And hopefully by reviewing these problems, it will help maximize your points for the midterm review. So we're going to start off with our first problem is a piecewise function. And I just want to remind you, when you look at a piecewise, it's basically two parts of a function that are coming together. So for the first part, the x qualification says that x is going to be greater than or equal to 1. So right here is 1. So the first function is going to be at y equals 4, and that's when x is greater than 1. So the line y equals 4 is horizontal, and basically it just is going to be appear when x is greater than or equal to 4. So I'm just going to fill in the line at x equals 1 solid, so we know that it's closed and it equals 4. The next one is a simple equation of a line, y equals -5 minus x. Now, there are a variety of ways that you could do this. I would make a table just to make sure you get it right, and I would put in the values for the table. I would start off with 1, and I would remember to leave it open because it says here that x is less than 1. So I put 1 in, and I put values in that are less than 1. So put in a value that's much, much less than 1, like put in -3. When you put that in, those values in, you'll get 2 points, and you'll be able to draw your line through those points. So when x equals 1, y equals -6. And for the next one, when x equals -3, y will equal -2. So now you have two coordinates you can plot. Remember, you have to plot the first one with an open circle, and the only reason for the open circle is because in the domain statement, it said that x is less than 1. So we're going to plot at 1, we're going to go to -6, and that's going to be an open circle. Then when we go to -3, we're implying at -2. That'll be solid, and because we know the equation is an equation of a line, we're going to draw a line through those points, heading to the left. And a little tip just to help you understand this a little bit better. If you look at the inequality, the direction of the inequality symbol will generally tell you, this is saying x plotted, and it's showing the arrows are pointing in the direction that the function will be existing in. So this is saying, the graph will exist to the right of 1, and this is saying to the left of 1, if you want to use it that way. But you can also just make sense of the inequality the way you normally have in the past. So that would be my graph for that open-ended function. And be sure to label these parts, like label that to be y equals 4, and label this to be, y equals -5 minus x. Remember to leave that open. And now let's work on number 2, which is a function transformation. When we look at a function transformation, when we're given a graph with points, the first thing that we have to notice is we have a few things going on here. First of all, there's no flipping, because if you had a flip, you would have a negative in front of the function or in front of the x inside the function. So there's no flipping, but there is a translation. So you're going to move all the points right 1 and up 3. Now we have one other wrinkle in this problem, and that is the scale factor. We're going to take whatever the function value is, and we're going to shrink it by 1/2. So what's basically going to happen is whatever you see here with the function, it's going to be 1/2 of what its original value was. So that 1/2 means that at 1/2 of 0 is 0. So that point's going to stay, but this function line right here is going to appear 1/2 its height. And the same thing with this function here. So basically you're going to see like a squeeze on the y-axis by a factor of 2, because it's going to like be reducing it by a factor of 1/2. So, so what I first suggest that you do is first take care of the transformation. for example, right here we have a point that's at -4, 0. That point is going to move right 1 up 3. So I'm going to go from -4, I'm going to go right 1. So I'm going to go right 1 up 3, and that will be the new location of that point. I'm going to draw the function in its original state, and then I'm going to squeeze it by a factor of 2 once I get my original function drawn. This point is at -3, 2. So I'm going to move that right 1 up 3. So I go from -3, 2, I go right 1 up 2, and that's where that point is moved to. Then I'm going to go with the next point from -2. This is -2, 2. I'm going to go right 2, which will put me at 0. Right 1 up 3. So that'll put me at that point. And then I have my coordinate at 0, 0, which is going to move right 1 up 3. So that'll put me there. My next point, which is at 3, -1, that'll go right 1 to 4, up 3, up. It's -1. So it starts here. I'm going to go right 1, up 3. So that'll put me there. And the last point at 4, 0, we'll go right 1. So we'll go to 5, and up 3. So go there. Now, this would be the image of the function if it were this graph. This would be the image for f of x minus 1 plus 3. But the one that they asked me to graph in the open-ended is 1/2 of x, f of x minus 1 plus 3. So what I'm going to do is I'm going to squeeze this function by a factor of 2. So this point, like I showed here in the graph, it's going to come down by a factor of 2. So the graph is basically going to appear like this. I just got to make sure I draw it straight enough. And the points would be, and I want to label the points, it'd be -3, 3. This point here would be in red, the red point would be -2, 4. This point would be -1, 4. This point would be 1, 3. It doesn't get squeezed because it's actually where the function originally was on the 0 at x equals 0. So this will be 3, and then this is going to be a tough one. This will be 4, -1/2. I'm sorry. -2.5 or 2.5. And the last one is at 5, 3. Hopefully this has helped you understand what to do with the transformation. Remember, the tricky part was dealing with the 1/2 factor. Everything is the same as what we did in class with transformations. We had a movement to the right by 1 and up 3, and then we just had to deal with this multiplied factor to change the shape of our graph, squeeze it by a factor of 2. Anyway, if you have any questions on this or you think you may forget some of this, you can always write notes down and we can go over it on in class. So the next video will be on question 3 of your open-end packet.